Welcome to video E415, word problems involving permutations. So really quickly, on the last lesson we talked about factorials, 7 times 6 times 5 times 4. Today we're going to be talking about permutations. Permutations are very similar to factorials. Ordering is important, but in permutations sometimes you might not be arranging all the objects, just a few of them. Okay, so factorials and permutations, think of orderings or arrangements of physical objects. Okay, so example 1. Nella is choosing a 3-letter password from the letters A, B, C, D, and E. No repetition is allowed, so it can't be A, or A, B, anything like that. How many passwords are possible? Okay, so for these problems, I'm going to show you how to do it by hand. It's easier than pressing buttons on a calculator. So we want a 3-letter password. So I'm going to make 3 dashes. Dash, dash, dash. I'm going to call this the first letter of the password, the second letter of the password, and the third letter of the password. I'll come up with a fun password. So, all right, how many ways can I have somebody be first? 1, 2, 3, 4. There's 5 possible letters. So there's 5 ways that can happen. Let's be fun and say we chose it to be the letter D. Okay. Now, how many different letters can be second? 1, 2, 3, 4. Okay, so times 4. Let's make it be the letter A. And now, how many different ways can a letter be third? 1, 2, 3. And you might have guessed, it'll be B. So there's 5 times 4 times 3, and you multiply that out, and you get 60. So there's 60 possible passwords. This one in particular password was DAB. Okay. I won't use the ping pongs anymore. Hopefully you get the idea. All right. Example 2. There are 6 swimmers in a race. There are prizes for first or second. How many ways can the 2 prizes be awarded? Well, how many dashes should I make? 2, because I'm only arranging 2 things. So here's my arrangements. First and second. Okay. Well, how many ways can a different swimmer take first? Well, there's 6 of them. So any 6. Once a swimmer took first, he could no longer take second. There's 5 swimmers remaining that can take second. And 6 times 5 equals 30. All right, our final example. There are 4 floats in a parade, not a very large parade. How many different orderings, again, orderings, arrangements are possible? Okay, how many dashes should I make? All 4. 1, 2, 3, 4. The first float, the second float, the third float, and the 4th float. Hey! If I'm arranging all the objects, it's just going to turn into that factorial that we discussed before. How many ways can a float be first? There's 4. Once I put a float there, there's 3 remaining. 3. Once I put a float there and there, there's 2 remaining. 2. And once I fill the first 3 floats, there's only 1 float remaining. He's stuck at the last. So I could have just done 4 factorial, 4 times 3 times 2 times 1, and I believe that's 24. So there you have it, word problems involving permutations.